afternoon, ladies and gentlemen. So, sustainability and budget cuts in green space management, which way forward is the title. So following last year's theme, what are sustainable landscapes? I sort of tempted my definition of it. So I'd say sustainable landscapes are where natural cycles perpetuate without man's influence. There are no inputs of fertilizer and pesticides, no need to cut grass, to prune, weed or take away unwanted biomass. So everything is recycled naturally, usually where it falls. So for environmental and financial reasons, interest is now being shown in adapting sustainable principles to urban landscapes. 12 years ago, Lyon Parks Department put into place its own sustainable landscape programme. The decision was motivated by an increasing budget and the politicians demanding more environmental awareness. It was actually started in 2000. The director at the time was called Patrick Berger, who asked me to put into place this programme. And it was shelved because the politics at the time weren't ready. In France, the mayor is all-powerful. He's democratically elected, but once he's in, he's the driving force behind a lot of the projects. And at the time, it didn't actually happen, and it was revisited 3 years later. So we started in 2003. So a programme with 3 distinct themes was put into place. Each measure should have a favourable environmental effect, training the workforce needed to adopt new procedures and techniques, and costs were monitored. So it was necessary to find practical solutions to problems, reduce the green waste budget, reduce the time spent grass cutting, find less labour-intensive floral displays, and achieve the political aim of 0% of pesticide use. So there then, a few figures of what the Lyon Parks Department is. I'll just let you go through them very quickly. I'll not read them all out to you. It's quite big. So a year of trial projects on different sites was undertaken before adopted across Lyon. So we were looking at recycling by different methods of green waste management, earthworm culture, co-composting, which is mixing animal manure with vegetable waste, mulching on slopes with the leaves that were blown off the pavements in the town, etc. We looked at thermal weed killing techniques to replace chemicals. That was a solution that actually cost money. You know, it's not as efficient as chemicals. It cost €2,000 more. Grass cutting height, frequency was reviewed across the city. Where do we need to cut grass? Because typically, the fellow on the mower will set off in March, and he'll get off his machine in November. And he'll do the same circuit, whether the grass is that high or that high. So we had to sort of say, right, no, you will not start cutting grass until it's reached a certain height, and you will cut it down to another height. And we had identified different areas around the city of different height, minimum and maximum. So we got a bit like a golf course with your rough, your semi-rough, fairways, etc., with different cutting heights. Again, we economised about €45,000 doing that. New low-maintenance planting schemes were put into place. Here we used a technique of fixed wood chips, which were fixed by cement, permeable. The water went into the water table. It could be cleaned by the street cleaners very efficiently. So it was all new stuff. And we used Durafloor urban meadows to replace about 70% of the traditional bedding across the city. Again, saving quite a bit of money. Needy and underprivileged members of the community were offered training and employment. What's happened was, I think it's a European law, but when work is put out to contract, 10% of the value of those contracts should go to social engineering companies, and that's what was actually done. So 10% of all contract values went into training for local people in the areas that didn't have access to full employment. So the results were positive, with an increased community employment, 20,000 kilometres of HGV transport economised across the city. We locally recycled the green waste with 90% reduction in herbicide use. Basically, there was a 14% reduction on the park's budget after about 4 or 5 years, and we could have actually gone further had it been required and achieved 20 to 25% reduction on the budgets. So that was where we left off last year. Now we'll go to this year. So in order to measure the economic benefits of changing maintenance practice, we need to know what we have. We need to classify the green infrastructure. We need to establish a baseline. And we need to do time and motion studies to know how long it takes to do the tasks. So this was a scheme that's, I think, used quite widely across France, and it was in Rennes in the 1980s, started doing this. Classifying, back one, it's the wrong one, this one. So classifying, class 1 would be horticultural excellence, which would be bedding schemes, very high, neat and tidy areas of the city. Class 2, high horticultural vocation, right the way down to traditional, semi-natural and natural areas. So we've got a class 1 to class 6, basically speaking. And then with that, we'd say, right, we're going to attach now a cost per square metre on the work we do. So that is actually an example of an area in a park in Lyon. And we looked at the mowing, the trimming, the shrub pruning, hedge cutting, etc. We knew how long it took to do. We knew what the surface area was of each one. We knew the total cost, and we got a cost per square metre. What is interesting in that the paper picking and the cleaning is a very large part of the cost. So the cost per square metre, the maintenance, was 36 centimes of €1 per square metre. But most of that is actually paper picking and cleaning and not actually green space management. So differentiated management is appealing for its simplicity. Each class will have its own specification document defining quality and operational frequency. The specification document is very, very important. If it's going out to contractors, they need to know exactly what they've got to do, with what frequency and to what standard is expected. So we could have a situation, for example, where we take an example with different lawns of class 1, class 2, class 3. Remember, this is more intensive maintenance. On the other side is more extensive maintenance. And you could have a city park which would have different areas of class 1, 2 and 3 here. And you can decide if the budget changes, right, we'll go down to a class 2 or to a class 3. So you can change your, you change your maintenance according to your budget. Quite simple. So really, parks, there's a lot of influences and choices and decisions. I listed a few of them I thought of here, or the categories of them anyway. But do all the participants communicate? I think that is one of the things I heard this morning. There's this lack of communication. We're all in the same business somehow. We're different sectors, whether it's research, whether we're operational or not. But what is the way that we can all communicate and bring all this expertise together? If you're going to put into place a sustainable maintenance program, a few questions. Are the objectives clearly defined? Is the internal process clear? Have investments costs been taken into account? Because you very often have to invest in new material. Will it run internally or with external help? And is everybody on board right the way across from the fellow who's pushing the grass cutting machine to the mayor of the town or the planning committee, etc. So when I was writing up this lecture, I wanted a few statistics of UK parks. I lived 30 years in France, and I came back to the UK about 2 years ago, and I wanted to sort of say, well, you know, how many parks are there in the UK? And so I put out a few questions and got one or two documents. And what is surprising is that the number of local authorities who do not know the number of parks they manage is 1 in 6. And the number of local authorities who do not know the surface area they manage is 35%. Well, how can you start off from a baseline if you don't know what you've got? The uncertainty of unsurfaced areas perhaps testament to the low value that has been attached to green infrastructure. So when monetary value is attached, accountants will surely know the areas with precision. So we've briefly looked at some of the maintenance practices and what can be achieved. What does the future hold? Where should we be going? How much technical and scientific information can planners and landscape architects access? And is long-term maintenance ever thought about at the design stage? So, parks and green spaces in a town generally reflect their socio-economic evolution. They are rarely planned as a whole. We add bits and pieces on, we construct a factory, we build a road. So the management of these areas very often follows the ad hoc fragmentation that exists. So we need to adopt a harmonious and holistic view of a city's functioning. So if we take an area, looking down on a particular city in the UK or elsewhere, what can be recycled locally and in what quantity? If we're talking about parks, can we recycle all the grass cuttings, all the tree leaves that are in this area? Where does it go? What does it do? So if we want to talk about an ecological equilibrium, we might need to talk about changing some of these surface areas and what their destination is. We'll take one example, We'll take a semi-mature street tree, a plane, London plane, 10 metres high, 30 centimetres diameter. How many leaves are going to fall off it? What is the weight of those leaves? What's going to be in 10, 20 or 50 years' time? If we've got landscape architects saying plant trees, but we don't know how many leaves are falling off, how much it's going to cost to collect those leaves, to recycle them, what's the point? We need to know the long-term economics of this sort of problem. Water, how much water does it need? Where does the water come from? Can rainfall runoff be used? Carbon emissions, are we talking about carbon emissions, carbon sequestration? We'll come on to that later. The tree pits, what is the soil quality like? What is the available soil volume? There are lots of questions revolving about just one street tree. If we multiply that by hundreds of thousands of trees across the country, we realise that we've got a lot of problems, and a lot of questions are asked that we don't have the answers to. So we need to know about the quantities and the long-term costs. So new landscape projects and existing green infrastructure needs to balance ecological coherence with amenity to use. We need to recreate living soils to reduce our dependence upon chemicals. The above-ground biomass should ideally be produced in quantities that can be recycled very locally by the natural decomposers in the soil. Amenity grasslands can help flood management. We can avoid toxic plants, toxic in the sense that laurel and conifer hedges hold acids that are difficult to compost, etc. We can use the capacity of plants to outcompete others, the plants we don't want. Mulching, use the low-maintenance grass varieties, use nitrogen-fixing legumes to reduce fertilizer requirements, increase the permeability of hardscape surfaces, and increase biodiversity, look at the longevity of landscape materials. There's lots of things that we can be doing. So we talk about carbon audits and looking at green infrastructure, and do you have a green infrastructure that is carbon negative or carbon positive? In 2010, I undertook a carbon audit at Romsey War Memorial Park in Hampshire. So to see really what was happening in terms of the carbon movements in the park. So it was a typical British park, about 2 hectares, and we measured the surface areas in the park, the sort of park you find anywhere across the UK. Sampled the tree, counted the tree, looked at the tree ring distances, and related that to the carbon increase, the biomass increase in the tree. And there's an example here. So basically speaking, that at 5-year intervals, the amount of carbon that's coming into the tree. What happened here, we think, was they did root pruning for the paths, which sent the growth rate. See the growth rings here a lot closer. So there's a lot less growth, so it's less carbon. And then it recovered, and it took 50, 60 years to recover. So what the results showed, that we have carbon sequestration coming into the shrubs, the lawns, the soil, the trees, the hedges. We've got a stock of about 778 tonnes in the park. The annual sequestration, the amount of carbon coming in was about 8 tonnes. In terms of emissions, which is just carbon footprint work, we've got 1.5 tonnes going out. So there's a net increase of about 6.8 tonnes of CO2 equivalent per year. So what we're saying is that parks and green infrastructure has an enormous impact on the capacity for absorbing carbon. But we can actually take it further, we can improve it. So as part of the environmental research programme near Angers, root growth and carbon sequestration in grass species and varieties have been compared. So here you can see the test grounds, you can see some of the root growth on some of the, that's probably tall fescue. And if you look at the summary of turf grasses and what actually happens, so you've got the different species here. But for example, in meadowgrass, in ryegrass, you've got between 3.89 to 18 tonnes of CO2 per year coming in. So there is an enormous difference between the different varieties of any one species. Now you will never actually put together a mix just for carbon. You use it for wear, for parks, or for football pitches, etc. But if we know the capacity for storing the carbon, you might as well add that into the equation and say, well, we'll choose those varieties rather than the other ones. So there you have really the differences, and there's quite a lot of differences between each of the species. So by selecting the better performing varieties of a typical amenity grass mix, sequestration may be doubled or tripled. if we sort of project the 2 hectares of Romsey Warmere Park to 150,000 hectares of UK parks in the same proportion of trees, shrubs and grasses, we find quite a lot of carbon. So 5.2 million trees would give you about 7 million tonnes of CO2 as a storage. It's been stored there, but coming into the system would be 177,000 tonnes of CO2 a year. Again, you have figures for the shrubs, which is quite a lot, but if you're pruning your shrubs each year, you're not getting a net increase. Lawns, you're storing your carbon in over 100,000 hectares of lawns of about 1.5 million tonnes, with a lot coming in. You see there's more coming in on the grasses than there would be for the trees, or at your annual sequestration rate. And by enhancing your park management, again on the sustainable principles I talked about earlier, you could actually be talking about putting in about 1 to 1.5 million tonnes of CO2 per year. And what is interesting, by increasing your soil density, a 1% increase in organic matter could add 50 tonnes of CO2 per hectare into the soil. So that's a few statistics just based on the results of that park. Part of the research programme was to look at low maintenance grass varieties as well at the research station. And clipping trials have been done between 2002 and 2011. Basically speaking, the trial plots existed and they were measured, and then the weights of the clippings was taken. And again, what we're finding with that are that with each species, you've got an enormous difference between the varieties of the amount of clippings that are taken off. I mean, it will vary. There were wet years and there were dry years, but even taking that into consideration, the varieties were fairly consistent from one year to the next. If it was a low year, it was a low year for everything, or a high year, it was a high year for everything. So with the commonly used varieties in grass mix formulations, there's a 2-fold or 3-fold difference in growth rates as measured by removed clipping weights. So conclusions. Various sustainable landscape maintenance programs have been successfully put into place in European cities. Management needs to classify and quantify its green infrastructure to establish a baseline from which costs can be monitored and future improvements measured. Our scientific and technical information base is poor. Planners and landscape designers need to access data that relates to the managerial decisions of the future. Green infrastructure is a carbon sink, even when the carbon footprint of maintenance is taken into account. And the carbon sink potential for green infrastructure can be increased. Improving the environmental quality of our parks and open spaces is not a technical problem, but a human one. But it will require significant shake-up in the way people and organisations function. So, sustainable landscape management does not mean abandoning maintenance. It remains a challenge to achieve horticultural excellence and impact using less intensive maintenance methods, integrating modern research, involving local communities and using renewable local natural resources whenever possible. Are you ready? Thank you.